Hello everyone, my name is Murtuza Shergadwala. I'm a data scientist at Fiddler AI. I like to take my coffee with milk. It can be any milk, but it needs to be milk.
Welcome back, everyone. This is another edition of the MLOps Community Podcast. I am your host, Dimitri Os, and today I am joined by none other than...
the one who shows up too much lately.
the incredible co-host, Abby. So we talked today to my man, Moto, as I like to call him, because he told me that was his nickname, and his real name is incredibly difficult for me to pronounce, but Abby can pronounce it quite clearly.
It's Murtuza.
Exactly. And he is doing some incredible work when it comes to how humans and computers interact and what the experience is, like the overall experience. Abby, what did you take away from this conversation? I had so many good takeaways and I loved chatting with him, but I want to hear yours first before I jump into it.
I mean, at least for me, the core highlight of it was the way he looks at the problems in the ML space, because for a very long time, we've been looking at all of the problems from very much like an engineering perspective, where we talk about, hey, this is the people aspect of it, but nobody was talking about the design aspect of things. And building the tools that we have available for us, which is the big ecosystem of the MLOps tools, building them from a human-centric perspective and thinking more so about what are the different ways we could think about those things. And I mean, one of the discussions we had around alerts, that was the highlight for me, at least for today.
Oh, speaking about the alerts, let me pull on that thread a little bit more, because I think one of my favorite parts was when he talked about how to gain trust with their customers, they see that their customers will set up alerts at 0 just to see what they're getting alerted on. And so when someone starts using Fiddler, they'll put their alerts and their alert threshold at 0 just to figure out what exactly it is that is giving them alerts, and to make sure that they're getting the right alerts, and that way they can trust that Fiddler actually works. So I thought that was a fascinating piece to dive into. Again, I want to echo what you talked about. The way he thinks about designing things and this human-centric design and looking at the whole picture is fascinating to me.
Absolutely. And I think a lot of it draws from his background working in XAI. And that is, I think, something that sort of needs to be merged in, especially when we talk about MLOps or designing future MLOps solutions. XAI has been very much focused, at least of now, towards reinforcement learning or robotics. I think more XAI people are absolutely required in the MLOps community.
And for those like myself that don't know what XAI is, can you break that down for me real fast?
So the goal is basically human-computer interaction, but a lot of principles of human-computer interaction do apply to the tools that we're sort of building, because for everything out there, we're basically building up these dashboards and stuff. And at every single point, you have, for every single action, we do have a feedback which is sort of received. And based on those feedbacks, the goal should be to design those tools. And while that has been there in, let's say, augmented interfaces, so for example, building any sort of entertainment system, tabletop systems where you can sort of move things on the screen and all of that, while that has been there in that community, I don't think at least the principles have been sort of transformed or integrated in the MLOps community.
Incredible. So let's jump into this conversation. A huge shout out to Fiddler for sponsoring this episode. If you are looking for anything explainability, you know where to go. We'll leave a link to their website in the description, because it is worth checking out. With guys like Moto at the helm, it is incredible. You need to see what he is doing and how he brings all of this subtlety that he has into the product. All right. And don't forget, Abby loves me to tell everyone you should like, comment, and subscribe. Give us a rating. Let us know what you think of these episodes, because we love hearing feedback, and especially if it is the honest kind that gives us a little bit of the chills when we read it. So that's all I got.
And also
Abby,
we have
anything else?
3 newsletters. He didn't stick to the script.
I love it. All right, let's get into this conversation with Moto. Moto. Yeah,
Hello,
tell me, Abby.
I didn't choose. Hi, Abby.
What were you going to say, Abby?
I was literally gonna jump into questions. I was like, let's butcher all the questions one by one.
Let's just get right into it. We're so excited to talk to you, man. We want to just go right into it. Well, what were you going to ask, Abby? Let's hear it. I want to hear your first question.
Yeah, I'm excited.
So one of the interesting things, particularly about your background for me, was you studied mechanical engineering and then you sort of transitioned into human-centric XAI, where more so I think a lot of your focus was towards human-centric development. So where did AI come in, and was that a sort of like a natural transition? Because you're right now working at Fiddler, and for me it was like, I wonder how he sort of moved into this direction.
Yeah, that's I think one of the most interesting things, obviously, that I like to talk about, which is, connecting the dots, as people say. I started my undergrad back in India in IIT Guwahati, which is focused, of course, on mechanical engineering, and I was always a human-centric, user-centric person. I just didn't know it at that time, or have the right words to talk about it. But mechanical engineering pursuits started with, Iron Man and Transformers and things like that, and I really wanted to get into that. Funnily enough, I didn't enjoy the field of robotics as much as I enjoyed people's interaction with the machines. And so
that's
then
interesting.
I had, yeah. So even though I was expecting myself to be in this robotics lab where I was going to be, participating in robotics competitions at college, I didn't do any of that. In fact, I was more focused on, getting to know people and what they are doing in the different areas and connect with everyone. And I had this social aspect going on. And because being in an IIT, it affords you opportunities to go on internships. I had an internship in South Korea. I had a study abroad in France. I had gone to the US for an internship. So I was literally away every year during my undergrad for all these different internship opportunities. And in fact, when I was at Purdue University in US, that's how I met my advisor. And then I came back and, just had a word with my advisor. Turns out he was my super senior from IIT Guwahati as well, which is crazy. And then I landed up, pursuing a direct PhD offer at Purdue. The focus of my internships, it also, of course, adds to that path, right? In South Korea, I was in the sustainable environment and architecture lab, and they were very interested in ubiquitous computing, and that got me into design. And then back at Purdue, it was the internship was focused on crowdsourcing. And then slowly the PhD topic, because I was connected to my advisor, that also got connected to crowdsourcing, that is leveraging ideas of the crowd, but focused on engineering design. And this was primarily funded by NSF, because NASA had all these robotics design competitions and these engineering competitions. And they realized soon enough that people were just trying to game the system, right? There's game theory coming into the picture. As soon as you put a $1 million prize on designing a robot, every left, right, and center person is going to try to participate in that. And the quality of solutions that you get from such an expertise-centric contest which moves away from like CAPTCHA or like some simple cognitive tasks that are crowdsourced to these tasks which are very knowledge-centric, domain-specific, and so on. The focus of my PhD then became how do you design competitions in a manner that you can predict the quality of outcomes that are going to be generated for these domain-specific areas. So that's how, really the whole, in fact, it's funny, like I moved from the crowd to a single human being as I was like, like to an individual, because humans are not monoliths, but, just even I realized that even on an individual level, like cognition, the mental processes and status of that, like we don't really understand that as much.
So true.
So that was like really my transition.
Dude, so there's something really interesting that I look at your background and I automatically think like this idea of decision-making behaviors of engineering designers in design contests. And basically what you were doing is trying to figure out how people are making decisions, if I understand correctly.
That's right.
And I look at my life and I think about how I can better make decisions. I'm always trying to, I'm actually quite slow at making decisions when I make decisions. And I also am like, I always want to do both. Whenever I'm faced with decisions, my biggest kryptonite is that it's not that I can't decide, it's that I decide for both. And so really trying to like go for one or the other. Now, I guess the question that I'm trying to formulate is coming back to the individuality of each person and the way that they make decisions. Have you found tricks or tips on how different people, is it like if I know my astrology sign, then I can better understand the way that I make decisions? Or what were you able to find over your time studying this? Because I'm just like incredibly fascinated by humans' decision making and the way that we go about that.
Yeah, that's an awesome, thoughtful question actually. And when I started as this like mechanical engineer, I really had a very different view of like quote unquote like social sciences. And the way I put it as social sciences is because I never thought of it as a hard science, because that's what was fed down to me as an undergrad, that engineering, STEM, these are the backgrounds to go into. And then I go into my PhD, and the first paper that my advisor gives me to read is the works of Daniel Kahneman and Tversky, focused on cognitive biases. And I'm like, what the hell is all of this? Like, how is this connected to mechanical engineering? Like, and so as I started reading a lot about that, and then von Neumann Morgenstern, and the idea of like utility theory and decision making and all of that, I was like, wow, like wait a minute, like there's just so much I don't know. And like, oh my god, like I've started a PhD without like any background in all of this. And so over the period of time, as I started like just firstly reading theory and just playing catch up with how people think, the idea of thinking fast and slow, like you're talking about like you are a slow decision maker. That's actually probably over a period of time where you might have made some quick decisions and like regretted it or something, right? Because like we learn over a period of time to not quickly respond or have these knee-jerk reactions, and that is really our cognitive mechanisms that are working to tell us, hey, like slow down. And that's what probably we term it as wisdom.
So true.
But yeah, like talking about like what I have learned, I mean, like there's just so much, like there are these like behavioral traits. Of course, there is cognitive biases and so on, but specifically with like engineers and designers, what I realized is that it is more of an inverse inference problem. And that's where the work of Judea Pearl and all of that like became very, very important to me, because I was using Bayesian approaches, and my entire work just started focusing on inverse inference. That is, given that we observe a bunch of decisions, can we infer the latent variables, which we can term it as cognitive variables, which are really like these beliefs that people have over an entire state space of actions or that they can take, what can we tell meaningfully about them by just looking at their data and then adding some theory with it?
So let me see if I understood that correctly, because I think there's something really interesting there when it comes to what you're talking about. It's basically you're just looking at the decisions someone makes and how you can infer and get and gain insight from the decisions, only the decisions, not anything about my personality or the things that I like or don't like. Well, I guess that's part of the decisions a little bit, or all of that plays a factor into it. But you're mainly just looking at the data on the decisions and then trying to gain insights. Is that what I'm understanding?
Yeah, that's right. I can concretize this by giving an example. So, of course, I've conducted control experiments and behavioral experiments as a part of my PhD. And since I had a demographic that is mechanical engineering students readily available to, participate in these controlled experiments, one of the settings that we had is that we really wanted to understand when mechanical engineering students are designing roller coasters, do they have a better understanding of the physics of the problem as compared to if English majors are designing a roller coaster? And so we gave them this sequential decision-making problem because design is an iterative process. We created this experiment where, we gave them this objective of maximizing enjoyment experienced by the riders of this roller coaster. And this is very true to real world, right? Like you're given this objective, but there's no mathematical quantification to it. So what do we do naturally? We conduct experiments, right? We start ideating on these different roller coasters, and then we start experimenting with them. And experiments can also range from, stress analysis of these coasters, to roller coasters, to actually asking humans who may be potential riders, do you like the color or do you like the shape or whatever it is, right? There's so many ways in which you can gain information. So in my PhD, I kind of abstracted this process on a higher level to create this framework in general of how humans in any field, they're essentially, any human is a designer when they're trying to, achieve an objective. Whether they are satisfying the objective or optimizing the objective, it doesn't matter. But the higher level process is that, you're given an objective, you seek information, you are sampling that space, you learn something from the experiments that you're conducting, you update your state of knowledge, and then you start either refining your experiments or improve the, the space in which you are. And again, do the same process until you finally say that, okay, I'm happy with the solution that I finally have.
And this is quite interesting for me because, this also sort of relates very well with some work I've read by Julian Tegelius. He's a game AI professor at NYU. And a lot of people in reinforcement learning are sort of working on these same kind of problems. But I want to take the conversation away a little bit from, taking the same foundations where you say, okay, let's understand how people are defining these latent variables to be decisions. You also had one of the papers, which is basically the human-centric perspective on model monitoring, where you said basically the stakeholders desire customization of model monitoring systems. Now, let's say we're talking more so about how do we design data infrastructure systems or any sort of MLOps tools. How does it apply over there, and how much customization is actually required, and what's the process to go about it?
Yeah, that's an awesome transition. So actually these human-centric preferences, when they are making decisions, ultimately the inference problem helps. Like if you can infer meaningfully something about it, it aids in being able to design systems that are human-centric. And so now if you are designing a model monitoring system, ultimately who is using that system? This is being monitored by humans who are looking at these, dashboards, or they are being alerted on maybe some data drift that's happening, or maybe the system is behaving in a weird way. Now, different people respond to information that is given to them in different ways. So some of these cognitive knobs that are there of how do you present information, is it visually important to them, or is it numerically important to them? all of that ultimately influences the decisions that they will take of like, oh, I do need to retrain my model, or I need more data, or let me inform my bigger team about this model drifting and how much drift is okay for me, right? Like these are all different decisions that people start making based on what they see. So I feel like this idea of preferences it really can be embedded into these monitoring systems, which are really the interface between the human and the AI when you are, you know, um, trying to create this MLOps framework on top of your ML system.
Very interesting. And how does it work from like the designer perspective of the people actually building these systems? Because I mean, it makes perfect sense from a user perspective, especially because a lot of people do often say, and that's one complaint that people have, which is there's so many dashboards available, but nobody actually ends up using dashboard. People buy dashboard and they just sit over there. And, you use them to create reports and stuff. And while that is a little bit different with weights and biases and Hugging Face, they do have pretty dashboards. But let's say we're trying to design a dashboard. How do we take that kind of approach, human-centric approach, to designing these kind of systems and to be able to make sure that we are actually providing that level of customization?
Right. This is a big problem, and it's not. There are no solutions for it. Of course, like UX researchers, UI researchers, like they really do all of this work, right? Like interacting with the users. Interestingly, now who is the user here becomes important. So, is it are you using, for example, Fiddler software? That is a company that I work at. Let's say you're using that software as a service. Are you a data scientist who's going to be looking at the dashboard, or are you a C-level exec who just wants a quick summary of what's going on? That changes the kind of features that you provide in this dashboard system. So knowing your audience obviously matters. What we have realized is that majority of the people, the clients that we talk to, it's funny that the decision makers are at the C level, but then the people who are actually aiding the decision are the data scientists and MLEs who ultimately talk about whether this thing is useful or not. So catering to the needs of both is important, both from a business standpoint as well as a utility standpoint. That dashboards and all those nitty-gritty details are going to be seen by data scientists or MLEs. In fact, we go to the level of separating out data scientists and MLEs, because MLEs might be incentivized in a different way as compared to data scientists for their jobs, where MLEs care about productionizing the data, they care about the model performance, and so on, whereas data scientists might care about the quality of the features, bring in their domain expertise. They want to be able to understand if any of the features are drifting rather than performance. And so catering to both of these demographics becomes very important.
One thing that I think about is something that I think you spoke to a little while back, and it's how explainability and just explainable AI as a movement and as something that is important in this field is very much changing as the field changes. And it is like evolving with the field, and considering how fast the field is evolving, whether that be on the modeling side or on the infrastructure side, the explainability is trying to keep up with that evolution. And so as you have your hat on of thinking about humans and computers interacting together, and then knowing that there is that evolution, how do you plan for that type of thing, like that happening, basically?
Yeah, that's a very awesome question with respect to XAI. And my perspective, since I'm this, I'm self-claiming that I'm a human-centered, design guy. What I have noticed is that, these explanations or these post hoc explanations that we have for explainability or these attribution-based approaches and so on, they are really model-centric. So they're trying to explain the model or at least they make an attempt to, whereas we are trying to present it in a very human-centric way. And that's where I think the friction is coming in, where, yes, ultimately on a higher level, we are trying to explain the model. So we want it to be, the human can build trust and understand it. But the techniques that are there, they are faithful to the model. And the way we are trying to present it is that humans are able to put in their own cognitive biases and try to really bridge the gap between what they see versus what they are thinking of. And the example for this is, like, for example, if you consider image explanations, and you have a model that is, doing a classification of, something like it's a bird or not a bird. And, we are trying to understand why does the model look at a particular image and claim it to be a bird. And we as humans have, certain features in our head that it should look at the beak, or it should look at the body, and it should look at the wing, and so on. And hopefully it's not looking at the sky or the clouds and, labeling it to be a bird. But when you look at these post hoc explanation approaches that are trying to show you where the model in general is trying to focus on, it is just telling you that, like, it's telling you that these are the regions where the model is focusing on. And we are the ones who are trying to, impose our biases that, okay, if it is looking at this region, that means it has to be looking at the beak, or it has to be looking at the eye, or it has to be looking at the sky. That's something that we are really adding on top of it. And I think that's where the big gap lies with explainability. That is training the people who are actually looking at these interfaces and letting them know the limitation and assumptions of these approaches is very crucial. And we can't sell it as a tool that is for anyone and everyone. Like, it's not like some person who has not designed the system, or a data scientist who does not understand post hoc explanations and their limitations can look at this image and look at the heat map, for example, and be convinced that the model is paying attention to these hottest regions, which means that, okay, it works. There's a big gap there, and I think it needs to be filled.
The thing that I'm thinking about is, you mentioned how you can't sell it to just anyone. Are there people like, and okay, so let me try and rephrase this. Let me see if I can put what's in my head into reality, because it's not always the easiest, especially on something. This is like a very mentally stimulating topic, right? So the idea here is, there's that gap, and you can't just sell this to anyone. It has to be someone who is interested in this, but also has almost like a vested interest, because it is important for their job or whatever they're doing. And I imagine regulations come into play, and so for some people it is absolutely fundamental. And then you mentioned how there's this gap of others that maybe they aren't educated on it, or they're just not interested. And so who are these people that you do sell to that fully understand and grasp the concept and are on board 100%? And then B, the gap, how have you been trying to bridge that gap to make it so that those that aren't necessarily in the know can be?
That's a great question. I think, of course, there is no static practice, right? Like, the practice is evolving as we are learning more and more about how users are interacting with our system. But I feel like it's almost like a user management cycle. Just like there's a machine learning model management cycle that you have all the way from, when you are training your data, to like productionizing and finally taking care of the life cycle of that entire design of the ML model. It's almost like hand holding and tutoring people as well in that entire life cycle, right? And that's where the human-centered perspective comes in, that it's not just about calculating drift and quantifying it, but it's also about how you present it to the human, and what kind of safeguards are in place so that you constantly debias them. Because debiasing is not just, oh, we onboard them and we tell them something as a, terms and conditions applied as a very little, tiny little, statement at the bottom, and then
Totally.
forget about it. It has to be a continuous process where you keep letting them know that what you're looking at is just the areas where the model is focusing. This does not tell you anything about the features. Hey, here is another tool that you could use in conjunction with this explainability approach to even, develop that complete picture of what is your model's accuracy, what is your model's performance. And it needs to be a constant debiasing, and that can happen through interfaces, that can happen through training, that can happen through periodic cyclical reminders. Because when you ask that question, right, like who are the people who are 100% on board, I mean, the people who are experts themselves get confused, right? Like, and that's where the problem is. It's not like these approaches right now are catered to all, and it's important that you are in hands of a company that cares about all these issues, right? Like, yes, there are tools, open source tools that are available, but it's really like the responsibility lies with the user at that point of time, that here's a tool, what you do and decide with it is totally up to you. If you do not have it managed, or if you don't have like a DS team at Fiddler, for example, that tries to establish relationships with all these people who are trying to use the software, you will not be able to have a communication about it. That, hey, it's been 6 months, I have been using this, here are some of the things that I have observed. And then suddenly we realize, as when we are talking to our clients, that, oh, actually, you know what, we need a feature in the software that lets clients know that this is not what you need to conclude, or this is what you need to look at. And that improves the whole UX, the user experience, but also ultimately improves trust. So it needs to be this very socio-technical interaction that is taking place even within MLOps.
Very interesting. And this does bring me to the question that there are quite a lot of ML monitoring tools out there. And one of the major focus for Fiddler has been, one is working on data integrity, and the other is more so working towards detecting outliers, alerting, and data drifts,
That's
and
right.
all of those things. But outside of that, there are so many open problems, because I mean the pipeline for an ML model is quite big. So it goes from model evaluation, testing, hardware metrics. You can also work about CI/CD pipelines and all of that stuff.
Yeah.
So are you specifically focused on just the data integrity and just the data part, which is let's help you out with this one, and then you use some other tool to work in conjunction on the ML monitoring, which is the model monitoring part?
No, so actually Fiddler provides this entire stack of solutions. So it's not just data integrity, but it's also model monitoring. And it is also looking at both production data as well as your training data, and you can set up alerts on that. In fact, monitoring is not the only solution that Fiddler is providing. We also provide explainability and fairness solutions. So it's like the 3 pillars, as we like to talk about it. And so once you onboard your actual model, then it allows Fiddler to even fiddle with the model and generate predictions and so on. If you're just focused on monitoring, then you don't really need to have your model on board. You just need the input data as well as the production data, and we can just look at data, including your predictions as maybe as a column, and see how it's drifting. But if you really want explainability as well, you have to onboard your model. And then we can start fiddling around with it, creating these, counterfactuals and so on, and understanding how your model is behaving in these edge cases. So yeah, all the 3 sort of pillars are there.
Very interesting. And I mean, as an ML engineer myself, one of the most annoying things for me is dealing with alerts, because there are so many alerts, and which alerts are important and which ones are not. And there's people to get tired. There's that mental breakdown as well, which happens sometimes, and everybody has to be on call rotations and all of that stuff.
Alert
So
fatigue.
how do you work around that? And how do you sort of understand, because you have experience in XAI, which alerts are important? Do we have sort of inbuilt systems, and how do we think about these alerting solutions? Because this is a problem area, at least for ML engineers.
100%. In fact, this my talk in NeurIPS was focused on that. So the human-centric requirements and challenges in model monitoring focus a lot on alert fatigue and cognitive overload. And how can you create a system? And this is not just for machine learning monitoring systems. Any alerting system, any monitoring system in general has these issues. But then how do you contextualize it to ML? Right, and if you can have this design framework of, okay, there is data, there is model, and there are model outcomes, and now if you can have this higher level design framework where there are these different bins in which you could start categorizing the alerts, you can, at least on a higher level of abstraction, let the user know that, hey, this is a data problem, this is a model problem, and usually in an organization, one person is not responsible for the whole thing. So if you can't there are two things, right? One is the alert system and how many alerts are being generated, but then the other is who is receiving those alerts. And so if there are ways in which you can direct traffic to the right kind of people for the right kind of alerts, that at least distributes the cognitive load on an entire organization rather than, one person. So there are several approaches that you can use, but again, it's a hard problem. It's not like there are already existing solutions in there. But I do think that understanding design frameworks, understanding what is it that people care about in an ML system in its life cycle, which person is caring about what. Maybe even, in the future, Fiddler, these are ideas that we throw around in the data science team at Fiddler, which is, maybe we can design an inverse inference system where we see what the user is interacting with to start categorizing the user into, okay, this is most likely a data scientist, or this is most likely a machine learning engineer because they're interacting with these different features, which can automate it and integrate it back into the alerts.
You said there are a couple of approaches. Can we sort of dig down into some approaches, and what are the limitations of each one?
Yeah, so of course, one of the things is, just starting with the user and doing user interviews and research in terms of what kind of alerts do they really, really want. Not giving them a decision fatigue by giving them a laundry list of all the different things that they can do, personalizing it to that particular client, reducing that space of possible alerts which are the most important for them. Maybe even creating systems that are dynamic in nature. Like as you interact more with particular alerts, they start showing up, earlier, or you prioritize them in that way so that users can learn to, but again, there's a trade-off there that, just because a user is interacting with a particular alert doesn't mean that another alert is not really important. And so there needs to be this domain knowledge infusion, even in something as simple as an alert, right? That, okay, what is the nature of this alert in and of itself? Is this a very critical alert, or is it just a seasonal effect or something that happened in the day? So adding those attributes, are also important, and it then, as you can see, like it slowly starts becoming a hard problem as to where you draw that trade-off. But these are the kind of approaches that I can think of.
And this is also one of the easy approaches I see around that, which is maybe actually a very easily thrown around solution, which is we define attributes for different kind of alerts, and using that we can sort of train a model to be able to identify those kind of things and classify these kind of alerts into different categories. But again, I also do understand that would be almost a naive approach, because for anything which is an outlier, it wouldn't be able to capture that one. And usually those are the most important ones.
So that's interesting. Could you expand a little bit on what do you mean by outliers in like are you talking about outliers within the alert system, or are you talking about outliers of the nature of the alerts that could be generated? At what level of abstraction are you talking about the
Oh,
outliers?
Just the alert level system, the first one.
Yeah, so there, uh, hopefully you're designing an outlier detection system in and of itself that is able to capture outliers and alerts. If, like, for example, if you're thinking about threshold-based alerts, already the threshold that you are setting for a particular alert, like, for drift detection, the value being less or above something, for threshold-based alerts, already it's pretty simple to detect all the outliers, because you know that anything above or below something would be an issue. But it starts getting complicated when you're just looking at data points in general and how far away they are from these distributional shifts. So there you don't want to attribute or characterize that alert as something that's not important, or something that you can ignore, or something that's at the bottom of the list. So I think that one of the things that can be done is that if there is a chance for outlier detection with a particular alert, then you automatically like make sure that you don't suppress that alert, because there is a chance for an outlier. If like for in a sunny day, if the alert can be, you design a system in a way that you're trying to avoid cognitive load for the user, and you suppress that alert. But then in one of those days when there is an actual outlier and the alert remains suppressed, then
not good.
then we run into issues.
Yeah.
Yeah.
Well,
So
dude.
yeah.
Oh, sorry. Finish that train of thought, and then I'll ask you the next one.
Yeah, so it becomes that design challenge, basically, that making sure that you are not actively suppressing an alert when you know that there is a possibility that there can be outliers coming along with it.
So what I'm thinking about is, when you mentioned beforehand what level of abstraction we're playing at, and thinking about the other type that you brought to the surface when you said, okay, what about the types of alerts that we actually are designing for? So maybe you have some cool alerts that you've been seeing and that you would suggest people to start looking at and putting into practice.
Yeah. So I'm sorry. So the question here was, trying to talk about all these different types of alerts
Yeah,
at that
so
level.
exactly. There's that, and just that playing field that you were talking about. Because one thing was Abby's question beforehand, how you mentioned, well, maybe we can train a model that can be predictive of these different alerts, but then it's hard to have those outliers. And when you're talking about what type of alerts that you put into practice, and there are outlier alerts that you might want to have. So what have you seen around that? Because that just feels like a rabbit hole that we could go down real deep, right?
Oh yeah. So I'll just give you one example, where we have this customer, and there was a lot of data integrity alerts coming up, and it made them realize that in the design process there was a little bit of muddling of null values, and what does it mean for the values to be null. And so, Fiddler being Fiddler started alerting, the client, the customer about, hey, I'm seeing a bunch of null values. And that actually triggered a different thought for the customer, that actually we haven't really put in a lot of thought on what is considered null. And so it's almost like the alert system, although it was intended as a data integrity violation, it turned out to be a chain reaction of thoughts, design thoughts,
For
which
sure.
people had to come back and evaluate as to, is this really a null value for us? And if it is not, then what is it? And that also triggered at Fiddler certain features, like where we, instead of saying null values, we call it fallback values, which is, the default values that a system is adopting. And every organization has a different approach to what is considered fallback versus what is null. So that's an interesting, chain of thought that an alert, even though we thought that it was intended for a particular thing, resulted in a different sort of alerting to the user. And that
Yeah.
helped us actually even further characterize it.
So hit me with some cool alerts that you've seen, or ways that you've seen alerts being set up, and creative alerts, or all the different types of alerts, if we're going to go down the alert rabbit hole.
So honestly, like some of the alerts that we see are pretty usual, right? Like, which is the drift metrics. Like, so we have this Jensen-Shannon divergence and population stability index, and these values being above or below a particular threshold is very interesting. In fact, some of the customers, just to establish trust, what they do is that they set up an alerting system at a zero threshold, and they want the system to alert them for everything. And that's how they start interacting with the system, which is very cool. So I like more of the human-centric observations, right? So for me, it's not more about the alerts which are being used, but how are they using it? And it's funny that alerts are actually a medium to establish trust with where initially they're just like, okay, let me just test this. Let me set a zero threshold and let the alerts fire for literally anything and everything that is happening. And if the system does that, then they start, improving the thresholds and seeing whether I'm getting alerted before they can be completely on board that, okay, I know that I'm going to be alerted on this.
Very interesting. And this, this entire conversation, I think this can go in so many directions, but one of the directions that does fascinate me, which is like, okay, this is one perspective. We think of it from a data scientist, a machine learning engineer perspective. But now, if you're designing sort of a monitoring solution, then how do you think of designing it basically, which is who's the person who's setting up alerts for, let's say, business executives who are looking at this kind of solution, or their marketing teams often are, or strategy teams that are often looking at these kind of solutions. And then there are data scientists as well, sort of somewhere into the mix. So how do we sort of develop any sort of dashboarding solution in a way that we are able to sort of customize things at different levels of the organization? And is that something which has to be done in a very client-specific manner, which is, let's personalize XYZ for this kind of client? Or can it be done in an industry-specific manner? Or is it let's focus on serving these kind of customers? So for example, like the healthcare kind of companies do have similar challenges as compared to, let's say, the kind of companies which I've worked with, which is basically e-commerce, and those kind of companies have very different kind of challenges. The kind of alerts that would be important for us might not be that very important for, let's say, healthcare kind of people.
Fair.
That's an awesome question. I think that I don't think there's going to be a one solution fits it all, for sure. I also think that doesn't mean that we stop thinking on a frameworks perspective, where, especially from an academic literature standpoint, like if there is research on how do you characterize a system and a subsystem, or even for a general industry, and look at different types of hierarchies and look at different types of interactions of these different teams, that actually influences the way product is set up. I think that we're going to see a reverse of that when it comes to softwares like Fiddler, where the way we are setting up this enterprise level software and the kind of people that are allowed to interact on this actually will influence the kind of discussions that take place between C-level execs and DS versus the marketing team versus, some sales team that wants to look at the complete picture. So to answer, of course, this is not really an answer, but I do think that having these higher level of abstractions, like these visualizations of org charts or system and subsystem designs, can aid in the design of our software as well. So we get very interested in understanding those organizational hierarchies and interactions, because that will influence the way in an enterprise people communicate with each other.
Dude, this has been so cool. Thank you so much for coming on here and just like exposing me to so many new ways of thought that I had never dug into before, and I find absolutely fascinating. I really enjoy this whole conversation and looking at human-centered design when it comes to doing things like model monitoring or just interacting with MLOps tools, because that is a whole different way of viewing the tools that I had ever experienced. And I really like the thought and the deep care that you put into how someone is going to experience Fiddler. And so thank you so much. This was awesome, man.
Yeah, this was super, super fun. I feel like I want to do more of these now.
Oh, well,
Easy.
we're
Mission
here.
accomplished.
Yeah, exactly. We're around. So, you got my number and we can make it happen.